What's up, everyone? This is LeetCode 79 word search. So we're given an n by n grid of characters called board, and we have an input string called word, and we have to return true if the word exists in the grid. The word can be constructed from the letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letters may not be used more than once, right? So basically, we're given a board with a bunch of letters, and we're given a word, and we have to see if this word exists in the board, basically, right? And we can go, and the word can be basically constructed by cells that are next to each other, meaning up or down, left or right, no horizontal, or sorry, yeah, no horizontal. I didn't mean to say no horizontal, no diagonal. You can't go diagonally. You can only go horizontal and vertically. Okay. So here are the words A, B, C, C, D, right? You can see you can actually construct it, right? Okay, so let's get into how we're actually going to do this. So we need to build out this word, right? So how do we build out this word? Just, right, like at a very basic level, we need to first find the first letter in the word, right? And then we can kind of start seeing if we can build out the word, right? That's really kind of our first step, right? And I will explain our solution as we go along, but I'm just kind of trying to break it down little by little. So overall, the solution will make sense when we actually start discussing it. So, so first things first, right? We're basically going to traverse through this grid, right, until we find the first letter. Okay, and now we need to do something. Okay, so basically we're going to go through this grid until we find the very first letter in word. When we do that, we can actually start using our algorithm, whatever it'll be, which obviously I'll explain it and implement it here in a bit, but that's basically our first step. Okay. Now, second step is, okay, we found the first letter, right? Now, how would we logically, like algorithmically find out this word? Well, we could check the adjacent cells, right? Obviously. Okay, so let's actually do that. You know, this problem is it is a grid problem where we're using DFS, so it's not exactly the same, obviously, as problems we've done in the past, but it is very similar. Where, I don't know, like rotting oranges or whatever, certain problems that we've done in the past with grids, where we have to do DFS. So it's basically what we're doing. So we're basically going to build out this word, or basically see if we can build out this word. Okay, but let's say this here is not a D. Let's say it's a Z. Let's say this board is bigger, right? For example, 1. And this here is a Z. Well, when we were going here, boom, to the B, to the C, to the C, to the E, and let's say this D is actually a Z. When we hit here, we see, okay, there's no D anywhere adjacent to the E here. If that were the case, we'd actually have to backtrack, right? And then move forward and then keep checking again. Because we could have an A somewhere else, like down here, right? The A at the bottom left. Now imagine this board was way bigger and had a bunch of other letters. Maybe the word isn't here, but it's down here somewhere, using this A instead of this A, right? So in a sense, it is kind of like a DFS problem, but it's also backtracking because if we can't find our word, we need to go back, okay? And keep basically iterating and finding out where the starting letter is, okay? So if you'll remember about these type of grid problems, right, there are certain conditions that we have to check. So we're going to make a function called backtrack, okay? We're going to need some coordinates, and we're going to need a word pointer, okay? Now, word pointer, right, the purpose of word pointer here is really, so our input word, for example, 1 is A, B, C, C, E, D. Really, our word pointer is just going to point to what letter we should be checking. So when we're here, we're at A, okay? Now, when we check the adjacent cells, we'll move the pointer, so we should expect the B somewhere. So when we check these adjacent cells from this A, we need to find a B. That's all that word pointer is for, okay? Is to know basically what letters we should expect. Okay. Now, this is kind of like this. First of all, we're gonna need some sort of base case, right? So, the first base case that would make us return is if we found the word, okay? How do we know if we found the word? Well, our word pointer, should basically be not 0, but at whatever the length of word is. That means basically because we only move the pointer when we find a letter that matches. So if the pointer is equal to the length of word, that means basically we already found the word, right? So we're going to say if word pointer is equal to the length of word, we can basically just return true, right? Because we found the word. Okay. Now here is basically a case where we have to handle some, not constraints, but basically some things that would make us want to basically stop and not continue on. One case is if we are out of position of the board, or the letter doesn't match what we expect, we can stop, right? Because basically, when we're at this A, we're going to check the adjacent cells and recursively check those adjacent cells and so on and so on. That's how our algorithm is going to work, which doesn't seem very efficient, obviously, but unfortunately, I mean, it's just the nature of the problem, which actually was a little bit shocking to me when I first did it. So first of all, so if our rows is out of bounds, or our columns out of bounds, or, right, I'll write this on a new line just so it's a little easier to read, or R is less than 0, or C is less than 0, or, so basically here is if the rows are out of bounds, or the columns are out of bounds, but we can also have a case where the board does not match what we expect. So board RC, right, if that doesn't match the expected letter, which is word at word pointer, right, that's a case where we don't want to continue on. Believe that should be it. Okay, sorry. I believe that should be it, in which case we want to return false, right? Because we don't want to continue on. Okay. Now down here is basically where we're going to do the checking and going adjacent to the adjacent cells. Right. And so this is where it's going to be a little complicated, in the sense that this is kind of the part of the problem where people can kind of do a lot of different things, because you can approach this problem differently. For example, how do you know where you came from, right? And the reason that matters is because you cannot use the letter cell. The letter cell may not be used more than once. So let's say the C was down here and the D was right here. So if we go A, B, C, D, when we're at this D, we don't want to hit this A again. Let's say the word was A, B, C, D, I don't know, like A something. We don't want to use this A again, right? Because you can only use a letter once. Some people use like a set, for example. Some people modify the input and change the board that way, which is what I'm going to do. But I just want you to know you can use like a set or something, or you can modify the input. I'm not sure. Like it just depends, honestly. Like maybe some interviewers wouldn't want you to modify the input, in which case you might want to use a set. But we're just going to modify the input. I feel like it's an easier approach. So we're going to have to store this in a temporary variable. And the reason for that is because let's say our input word is ABC, A, B, C, D, A, F or something. Well, let's say we go to this A, to this B, to the C, and let's say this is a D and this is a C, right? So if we go A, B, C, D, well, we can't use this A. Let's say we don't have any A's anywhere. Well, when we go back, we want to basically unmark these cells because we haven't visited them yet, right? Technically, because we didn't find the word, right? We're not doing any checking. So we want to unmark these because we can use them for the first time again if, let's say, the A is here, for example. Basically, the point of the marking really is just so we don't use a letter more than once, right? But obviously, if we don't find a word and we're backtracking because we couldn't find a word, we hit a dead end, basically. And we want to unmark our board, basically, so we can reuse those letters in a different word search, right? So we're gonna store the current letter in a temp variable, and then we're gonna mark it as basically seen by doing this. The reason we're storing a temp variable is because whenever we backtrack, we'll use a temp variable to basically assign board RC to whatever temp is, right? Like I said, you can use a set if you want. You wouldn't have to do this, but This is just how I choose to do it. Other people have done it this way as well. Okay, now here is basically where we're going to do the recursive call. Okay, remember this is like a DFS type problem, so we're going to say backtrack. And what do you know about checking adjacent cells, right? You check r plus 1, r minus 1, c plus 1, c minus 1, right? So that's what we're going to do. So we're going to say backtrack r plus 1, c, and word pointer has to go up by 1, obviously, because when we're at this a, if it matches, it'll 100% match, by the way, because if it doesn't, then we'll enter this if statement, right? Because we have this condition here. So we know that at this point, it should match. So word pointer should go up by 1, because when we enter that recursive call, we're no longer looking for the A, we're looking for the B in word, right? Remember, that's all word pointer is for, is basically for checking which letter we actually want to match, okay? So we're going to do this. We're going to say or, right? And this is basically we're checking all the cells, so I'm just going to do some copy pasting here. Right here it would be r minus 1, or, and here we'll just do c plus 1, and then here, or, and here we'll do c minus 1, okay? And then up here is basically where we reassign board RC to temp, because at this point we would exit these backtracking recursive calls, right? And notice how this is a bunch of or statements, so we're basically checking all the adjacent cells, and from there we're basically doing recursive DFS calls on all those adjacent cells, assuming they're in bounds. Yeah. So then we return answer. If we find the word, one of these should return true if we find the word, right? So whatever answer is, it's going to be true or false. Whether we find the word or not, really answer is going to be the answer to that. So that's basically our implementation of our backtracking, okay? Now here we have our for loop, okay? Remember, this is where we're just going through and finding the first letter for word, and then basically starting the call on we're starting the backtracking call, starting at that cell, okay? And the way we're going to do that is what? We're going to say basically, remember, backtrack is going to return true or false depending if we find a word. So we're going to say if backtracking rc0, right? If that's true, this will return true if the word exists. So if true, return true, right? And remember, this here is our word pointer, which initially is 0, because we're only looking at the first letter right now, okay? That's basically just our call. Now down here, if we exit the for loop and this never returns true, it means we never found the word, so we have to return false, because this word cannot be constructed given the input grid, okay? Little bug or something. Oh yeah, I did not name this right. Backtrack. I copy pasted all of these with the misnaming my function. Forgot the K. Believe that's it. We'll run this. So yeah, should work. Yeah, this problem is a bit tricky to come up with on your own for sure. Just because this solution seems so inefficient, you would think there would be a simpler solution, but this is just the optimal one as far as I know. I mean, if you know a better solution, let me know, but this is the one that makes most sense. Like I said, like this whole assigning a pound to a cell that we already visited, and then reassigning it with temp when we backtrack. You can use a set. The same concept would apply though. Like when you add the grid cells or the coordinates for that particular cell to the set, you would have to unassign it at some point when you backtrack, right? So I mean, you can do it either way. I don't know. Up to you how you want to implement it. I don't know if I mean you are backtracking and reassigning it, so I don't know if an interviewer necessarily would care or not. I think it just depends, but You can use a set if you want. You can do this way, but there are multiple ways to kind of. I mean, the gist of the solutions are the same, but they're slightly different. But there are multiple ways to kind of approach this in a sense, depending on if you want to use a set or not, things like that. But anyways, I hope this helped, and I'll see you in the next one. Peace out.